Hello, so I'm going to go over how to do a couple of these mole-to-mole stoichiometry problems. These ones are a little more complicated than the ones that we did yesterday, and I'm going to do a few examples for you, specifically the ones for number one right here. All right, so the first part asks, how many moles of FeCr2O7 are required to produce 44 moles of CO2, which is carbon dioxide? So the first thing that you should do that's really important is kind of what I did yesterday with the highlighting. So what I want to know is this and this. So these are the only two compounds that I care about. So I'm actually going to highlight them in my reaction. The nice thing about doing this like on the computer is that you can highlight and then kind of delete it and highlight it and delete it, which is kind of nice. You don't have to go back and like erase things. All right, so we're looking at FeCr2O7 and CO2, and I've highlighted those. So you'll notice that 4 moles of the Fe compound are needed to create 8 CO2. So I'm going to write that out, all right? So that means 4, I'm going to put FeCr2O7 over 8 CO2. Okay, so it's a 4 to 8 ratio, which is actually a 1 over 2. I'm not going to go into that too much because I don't want to confuse anybody. And then, so if I have 44 carbon dioxide, how many of the FeCr2O7 am I going to need? So let's do it. So here's the thing. So if this is 44 CO2, what I want to know is what is this number up here, all right? Again, the easiest way to do this is to cross multiply. So what I'm going to do, grab another color here so it's a little easy to see what I'm doing. So I'm going to cross multiply 4 times 44, then 8 times this question mark, which I'm going to just change to x. Makes it a little easier. It's more mathy then. All right. So I'm going to grab my calculator. Nope. All right here. So it's 4 times 44. Which is 176, okay, equals 8x. So I'm going to write that out. And again, you don't have to write out every single thing here. If you can do this without writing it out, that's totally fine as well, right? And then obviously to solve for x, we have to divide both sides by 8. All right. And that's going to give us the number of moles of this that we need. So I'm going to take that number, switch back from this, all right, divided by 8. And we get 22. Right? So my answer is going to be 22 moles. And that's it. All right. It is the same thing that we've done yesterday. The only difference here is the numbers are a little bit funky. They're not necessarily numbers that you could do in your head. So yesterday's numbers were pretty easy. You could kind of divide and multiply in your head. These ones are a little more complicated. Some of you probably still can, but even I always kind of check my answers in the calculator just to make sure. All right, let's do B. I will choose, go back to my other color. All right, so green. All right, so how many moles of O2 are required to produce 107.9 moles of Fe2O3, which is iron 3 oxide. So, same deal. I'm going to look at just those two. And actually, what I'm going to do is I'm going to clear the other things here to make it a little easier to see. So we're going to do B now. So I'm looking at O2 and I'm looking at iron oxide. All right, so I find them up here. Again, best thing you can do is highlight these. All right, that way you know what you're looking for. Everything else in the equation here does not matter. We don't need it. Okay, so we can see it's a 1 over 2 ratio. Okay, so I'm going to go 1 O2 over 2 Fe2O3, okay, equals, and then I need 107.9, all right, and that's the FE. Okay. Fe2O3. Okay. And then again, my question mark is on top, right? I want to know how many O's I need. So, same thing. I'm going to cross multiply, right? Now, this is 1, not 10. Looks like 10, but it's 102. Okay. So, when I cross multiply these, and I will change the color again. Hopefully, that's helpful. If not, that's okay too. Right? So, this times this, and this times this, which again, we're going to make this x. Right? So, you get 2x equals 107.9. All right. Which means that total moles, if I divide both sides by 2, this is solve for x. I should do, let me just show you on the calculator just to make sure. So we get 107.9 divided by 2. We should get 53.95. Okay, so 53.95 moles. If you round out to 54, that's totally okay. Close enough, right? So we get 53.95 moles. All right, that's number 2. We'll do the last one, and then we'll be good to go. Sweet. All right, so I'm going to clear everything out again. So we have 309 moles of, again, we're using the FeCr2O7. All right, so I'm going to highlight that one. And then we're using O2. All right, so O2. So we see we have 4 over 1, right? Cool. So, back to green. So we do 4 of the Fe, and I'm just going to write Fe on the top here just because I don't feel like writing the whole thing out. 102 equals, and we got 309 Fe, and then question mark, right? So again, cross multiply. Let's do it. Right? Again, this is x when we cross multiply the little question mark. So we should get 4x equals, oops, that's 309. Okay. Divide both sides by 4. I will do this on the calculator because it is late and I am not going to try to divide that in my head. So 309 divided by 4. 77.25. All right. So we've got an answer of 77.25 moles. Pretty easy. Again, this isn't too bad. You're going to get some weird numbers. I did that on purpose. I actually changed the numbers. This is an old worksheet. And I've changed the numbers a few times to kind of make them a little more tricky because I think it's nice to see that when you're doing chemistry, you're not always going to use whole numbers. If you're measuring stuff on a scale or you want to convert moles to grams or you're doing some sort of equation where you need a really random number of things, you're not always going to be using perfect, beautiful whole numbers. That's really important. So hopefully this was helpful and have a wonderful, wonderful rest of the day. Last worksheet, you guys. Last one. Yeah. So cool. I know, so exciting, right? And thank you for doing all the things that you have done. All that work. You guys are wonderful. Woo.